vehicle architecture. Here we'll see how will be the automobile, car architecture, what are the assemblies included in it, and what is the importance of each assembly, how they are connected to each other, that we'll see. Then the material selection, as the topic itself is a BIW, then for particular BIW, how the material selection will be done or what kind of materials are used, that we are going to see. Structural analysis and optimization. So on the BIW, which are the different kinds of structural analysis we'll do, and what will be the way for the optimization, that will be seeing. Then the different joining techniques. So here, how BIW components or parts, they are joined with each other, that we will see. Then crashworthiness and safety. So here we'll be seeing what is the role of BIW in crashworthiness and safety. Then the manufacturing consideration. In this, we'll be seeing what are the manufacturing techniques and what is the feasibility of the manufacturing while manufacturing the BIW, that we'll see. NVH analysis, brief I'll be telling about it. And the integration with other assemblies. So it is similar to vehicle architecture. So while explaining vehicle architecture only, we'll be dealing with the this only integration with other assemblies. How BIW it is connected, or how other assemblies are connected to BIW, that will be seen. Then design validation and testing. How the design validation it is done, or how the testing will be done, followed by one small video that we'll be seeing. So the overall, as it is, the timing is 45 minutes. So we'll be going brief and everything. So let's go for the next slide. So vehicle architecture. So as we see in the center of center image, it is the entire car. So car, there are different assemblies in the car, powertrain, like AC, or like roof system, architecture, battery system, seating system. This is cockpit, okay, or instrumental panel, what we call steering, and chassis and body shell. So this is the one typical kind of car. There are few cars are chassis based car, or few cars are monocoque car. So different assemblies are they have to connect with each other. So main element to hold this all is nothing but BIW. BIW is nothing but it is a structure, or we can call it as a skeleton of the car. Okay, so which provides the structural integrity to the car, or structural stability to the car, and all the components are connected to the BIW with the various joining techniques. Okay, so let us go to the next slide. So what are the main components, or the sub assemblies, what we can say? The chassis. Chassis forms the basic framework of the vehicle and provides structural strength and support. Okay, so if we see either it is car, in the monocoque car, chassis will not be present, or in the chassis based car, if we see, there will be two long members in the chassis and a few cross members will be there, and all the parts, okay, all the sub assemblies are fitted to those chassis. So chassis holds all the components and it provides the structural strength to the our car. Next comes powertrain. So powertrain, it includes engine, transmission, drive shaft, differential, and axle. What exactly it is required to transfer the motion to the wheel. Wheels are the moving components or moving parts in our car to make the wheels rotate. Okay, what all the assemblies are needed. So those are all included in powertrain. So those will be engine, then transmission system, then drive shaft. It is connected to the rear wheels, and differential, and then the axles, front axle and rear axle. So these all comes under powertrain. So powertrain is also connected to the BIW itself. Then the electrical system is there. Electrical system, there will be various it includes the battery, okay, or some wiring, everything. Okay, if it is electric vehicle, high voltage battery will be there and low voltage battery, both will be there. So this is electric system, again it is connected. Then the body exterior. So BIW holds all the exterior components also, such as, I mean, it will include the doors, everything. I mean, doors, the roof, okay, all these, or our like bonnet. These are all exterior parts which we can see out from the outside of the car, or even fenders are included in it, and tailgate also included in it. Okay, then these all are also fitted to the BIW by different joineries. Okay, so or joints, there may be revolute joint or some other joints will be there, hinges. Okay, those with the other joints, these all parts are connected to the BIW. Then comes interior. So in interior, it may be the trims, door trims, or the BIW trims. Okay, or your like it our seating system, or instrumental panel, or HVAC, heating, ventilation, and air conditioning unit, infotainment system, where it is nothing but screen where we can visual see everything. Then the dashboards. Okay, so all these are the interiors. These are also connected to the BIW with some fitting techniques. Okay, then comes the other like safety systems. So these are the parts of the vehicle architecture. This may not be connected to directly to the BIW. So here comes various airbags, seat belts, and that all. Even seat belt is connected to the BIW. How that we'll be seeing in the one of the picture later. Okay, then the suspension and steering. Okay, so fuel system. So fuel system can be of various types. If it is electric vehicle, it will be the battery. If it is CNG, those will be the cylinders. Cylinders will be there, one or two. Then the cooling system. So for the battery and also for the vehicle. So here comes like our radiator and that all. So those all are included in the cooling system. And otherwise, yeah. And in the braking system. So braking system, to stop the motion of the vehicle, what brake system it is required. So that is, so these all are also connected to the BIW. Okay. So when we go for the manufacturing of the BIW, so how should be the selection of the material? So material selection will be based on few parameters. So the main parameters I have included here. So first comes is strength and rigidity. So BIW, as I said earlier, it is the main skeleton, or otherwise skeleton, or it is the main component in the vehicle. So which holds all assembly, all sub-assemblies. So it should have the enough strength to hold it. Okay. And to provide the good stability to the vehicle, it should have the good strength, right? So what should be, so some high strength materials we use. So in that the materials are classified as high strength steel. Okay, so majorly because steel is mostly used. Other than steel also there are some other kinds of materials used in BIW, so which we'll be seeing later, the advantages and disadvantages of it. So high strength steel, ultra high strength steel, okay, and advanced high strength steel. Okay, so these all are like materials based, they are used based on its strength to weight ratio. So ultimately when we see the material, okay, when we choose the material, ultimate goal should be, it should have the good strength. It should have the good strength and it should have the low weight. Then only our efficiency of the vehicle or the mileage of the vehicle will be more. But at the same time, the cost also should be, we should consider towards the cost also. So it is not always that everywhere we need the ultra high strength steel materials only. So it is because when vehicle manufacture, it goes is through the various loading conditions. Okay, so wherever as per its function, the strength we should try to maintain it. Okay, so that we'll be seeing when we see some of the some of the videos related to the crash. Okay, that time we'll get to know where which components or which parts should have good strength and which part should have low strength. So as I said earlier, to have a good efficiency, we should have the less weight. So weight reduction is also one of the main parameter while selecting the materials. Okay, so as we know, steel. Okay, steel is the major material which is used entire all over the BIW. There are different grades of steel based on its yield strength. Okay, and the yield strength depends upon the various heat treatment processes. Okay, so weight reduction. So steel has the density won't changes much with the heat treatment processes. So density remains same. So the weight of the steel will be high. So to overcome from this, okay, disadvantage, okay. So the aluminum is the alternate material, okay, which we can think of. Okay, so aluminum has the low weight, okay, so but it should provide the good strength. Okay, so for make it good strength, okay, and the aluminum directly it cannot be used, so aluminum has to be used with some other other materials, so like some carbon fibers, reinforced polymer and that all, okay, or aluminum silicon carbide, like that. Okay, so different kinds of, with different kinds of combination, aluminum has to be used. So ultimately while preparing this material, so the cost will increase, the manufacturing cost or preparing the material cost will increase. So though the aluminum may provide the good efficiency, but the cost will increase. Next comes one more material which is much better than the aluminum. That is nothing but again magnesium. But magnesium cost availability wise, magnesium is less available, and the cost of the magnesium is also too high. But the strength wise, again magnesium has some good yield strength. Okay, then while as I said earlier, during the crashworthiness, it is not always required that we should have the stiff material or strong material or high strength material. So high strength materials are required, but sometimes the material has to be weakened, the stiffness of the component should be less, so that time we can use the materials or the weak materials which can absorb the more energy, like that. Okay, then the manufacturing feasibility. So when we are selecting the materials, as I said now, steel and that all. So steel and that all, BIW, in BIW, connecting steel with each other, or it is easy. Okay, so assembling steel parts or with steel part, it is easy, directly we can weld. But welding with aluminum and the other composite materials are a bit difficult. Okay, otherwise connections may not be so strong as that of steel. Okay, so some other joinery processes are required in the BIW. So because every technology or everything has its own advantages and disadvantages. So based on our requirement, we need to select what kind of materials we required. So there is the next parameter like cost. This already I have explained. So cost, it is aluminum has aluminum and composites. Weight reduction will be there. So overall weight wise we can reduce the weight will reduce. So like that, material required will be less, but again it is more expensive. So all the parts, okay, all the materials what we are using for our BIW parts, those will be corrosion resistant material. They should be. So galvanized or coated steel is commonly used to enhance the corrosion resistance. And aluminum, as we know, aluminum normally forms a protective oxide layer. Okay, so this is all about corrosion resistant cost. So next comes noise, vibration, harshness analysis. So as per the NVH requirements, what should be the material? Okay, so some of the other energy absorbing materials we should or insulating materials we should provide, so that the vibrations or those can act as a damper and they can reduce the vibration. So some kind of materials are also available, so that we can use along with our conventional materials. So next comes design flexibility. Materials that offer design flexibility and can be easily shaped into the complex forms are desirable for innovative and aerodynamic vehicle design. Aluminum and composites have an advantage in this regard compared to conventional steel. So design flexibility in the sense, what different complicated shapes are there, those are, those can be easily manufactured with the help of those materials. So like that it is. So next comes next slide. So here in this picture we have shown what kind of steel, okay, what kind of strength of steel it is used in which all regions. Okay, so some of the materials are like press hardened steel, high strengthened steel, okay, so dual phase steel, Taylor blanks. These are like joinery process. So dual phase steel, it is nothing but I have like um, I have kept the picture over here. So it is like ferrite martensite DP. Okay. So here ferrite and martensite both will be there. So these are dual phase materials are achieved by the heat treatment process. Because if we see the treatment process of the steel, okay. So steel, when we do the heat treatment at a certain temperature, we heat it almost around 1200 degrees centigrade or something, then it will reach its austenite state. So austenite, and then when we cool it, so cooling techniques may be sudden cooling or slow cooling. So based on that, the structural changes will happen. So while from the austenite, if we go for sudden cooling, then the martensite will form and few of the ferrite structures will be there in it. Okay, if we go for slow cooling, then the perlite, benite, some of the other forms of the like steel may form. Okay, so which will have the different properties. Martensite has the very good strength because it is in the form of HCP. I mean, initially the austenite will be in the form of FCC, face-centered cubic cells, and when it comes into martensite, it will convert into hexagonal close pack cell. So HCP has the more packing ratio, atomic packing factor of the HCP or martensite is more. So that is the reason is martensite provides the good strength. Okay, so such kind of high strength material which we can use it. So when selecting the material, we should think of the availability also. These materials are available in the form of like certain mm to certain mm only. I mean, lower limit and upper limit will be there. So in this table, you can have the view on this table. So here hot rolled steel tape, from what kind of thickness to what kind of thickness it is and what is the strength of it. It is written over here. So based on our application, based on the analysis what we do in that, what is the requirement, based on that we can choose the material based on its availability. And next comes the two different kinds of material of, because usually in the BIW all the parts are of uniform thickness. Okay, so they are nothing but everywhere the uniform thickness will be there in the one component, but in the Taylor blank joinery process, so in one component only we can have two kind of thicknesses. Okay, two different thicknesses and two different material grades can also be possible in this. This is what I have shown in the right side image. Yes, so let us go for the next slide. So structural analysis and optimization. When we prepare the vehicle, as I said, BIW is the main holding unit. Okay, or it is the core skeleton of the vehicle which holds the all units. So it should have the good strength. Okay, it should have the good strength. It should carry all the weight of those components and it should not deform or something. Okay, it should do its function as per the requirement. Okay, so different kinds of analysis are there. Stiffness analysis. Okay, so here means the BIW should have the good enough stiffness. So the stiffness will be of the different types: the modal stiffness, torsional stiffness, bending stiffness. These are the some of the stiffnesses which we see overall the BIW, all over the entire BIW. I mean, globally we see. So these all stiffnesses it should achieve. So every stiffnesses will have some the standard set. So standard limit set. So that limiting value we should try to achieve it. And if not, we should change the design and then we should try to get it. How that will be seeing in our upcoming slides. So next comes strength analysis. Strength analysis is similar to like the stiffness analysis, but in the, I mean, whatever loads we are applied. Okay, so whether the BIW has that much capacity or no to hold it, or how it will deform, or how many, what are the stresses are generating in it, whether it is crossing its yield limit and whether it is entering into the plastic region or what, these all things we will be checking in the strength analysis. Next comes is like optimization is also one of the like key component of the structural analysis. In the optimization, see, as I said, BIW or the every component, every design component should do its functionality. So when it is doing its functionality, it is so we cannot increase the weight of it, because suppose think one of the component, it is failing for like some 100 Newton of load. Okay, so I want my design, my requirement is that component should hold the strength of 100 Newton of load. Okay, so it doesn't mean that I should increase much of the thickness of that component or I should increase the weight of that component so that it will hold the 100 Newton of load. Rather than that, so we should try to change the design of it, okay, so that it should hold the 100 Newton of load. So it is the easy process. And the optimization also we should think. So in that optimization, the shape optimization will be there. Otherwise, or the topology optimization by changing the thickness. These are some of the techniques for the optimization. Okay. Well, then comes validation and testing. So when we are carrying the analysis in the software, like computer-aided engineering analysis under the various loading condition, and when we optimize the design, next comes validation and testing. Okay, whatever we have done, whether it is correct or no, see, because for the computer, if you give input, it will give the output. But have we provided the correct input to the system? Is it giving the correct output? So that has to be compared with the test. So physical test has to be done on the vehicle, and the result of the digital evaluation what we have done and physical testing what evaluation we have done, those both results we should try to compare it. And if it is not like matching, so where is the delta, where is the change that we should try to see and redesign it as per again the requirement till it's fulfill its functionality. So let us go for the next slide. So there are different kinds of, as I said, when the stiffness analysis or the structural analysis. So there are different kinds of analysis. So first comes it is modal analysis. Okay, modal analysis. Next is like bending stiffness analysis, and it is like torsional stiffness analysis. So here in the first, in the first image, there are different kinds of mode. It is animation is not playing actually. It is those are GIF file, but I don't know why the animation is not playing here actually. So whenever we are applying load on any component, okay, so all our mechanical, like the main, the equation, okay, equation is F is equal to mx double dot plus cx dot plus kx, okay. So F is the force. So in the modal analysis, usually what will happen, the force in the natural modal analysis, okay. There in the modal analysis, there are different types, natural modal analysis or something force modal analysis. So in the natural, when we want natural frequency, so the applied force will be 0. The body is made to vibrate. So initial excitation is given to the body and body is made to vibrate on its own. And then we see the functionality. So what is the natural frequency, what we'll calculate, and mode shape will calculate. In this time, the F will be 0. So the equation becomes like mx double dot plus cx. X is the displacement. I'll explain the terminologies first. X is the displacement. So if we differentiate displacement, we'll get velocity. X dot is velocity, x double dot is acceleration, and K is nothing but stiffness. M is mass or inertia, you can say. C is damping coefficient. Okay, so each has its own significance. So in the modal analysis, initial excitation will be 0 here, this F. So mx double dot, and as it is natural, so damping factor we are ignoring, so C will be gone. So the equation becomes mx double dot plus kx is equal to 0, and this will be x. This will be the differential equation. So for this, x is equal to a sin omega t is the, when we solve the differential equation, we get x is equal to a sin omega t. and that a sin omega t, and if we differentiate x double dot, like we get minus, sorry, a cos omega t into omega, and those all terminal, and one more x dot minus a sin omega square minus a omega square sin omega t we will get. So those things if we put into the equation, final equation, what we will get it as omega n is equal to k by m, which is the natural frequency equation, which everyone you have studied in your engineering, right? So through that we will get it the natural frequency k by m. Okay, and if we solve the again the matrix, okay, matrix, then we will get the eigenvectors. So the eigenvectors represents the mode shape, okay, mode shapes, and the eigenvalues what we get it from, because here the k will be also in the form of stiffness, m is will be also in the form of matrix. M and k both are in the matrix form. So when we solve it, the equation, so what eigenvalues and eigenvectors will get? Eigenvalues represents the natural frequency and eigenvectors represents the mode shape. Okay. So how do we, so what we will get from the this natural frequency and the mode shapes? So in the mode shape, we will get to know the what kind of the type of vibration, okay, in which direction it is vibrating. In the first slide, if we see, in the first this, if we see here the front part of the BIW will vibrate in the like this direction, lateral direction, okay. So and in this the roof it is vibrating or oscillating. So here the wherever it is, we calculate the strain energy here, and wherever the strain energy is more, then we will try to provide the stiffness, and if you increase the stiffness, we'll increase our natural frequency by this thing. And similarly, wherever the strain energy density, it is like less, I mean there we have chances of optimization, there we can have the cutouts and that all, and we can reduce the material, and we can scale down our natural frequency. Okay, we can get our target natural frequency. Okay, so what stiffness is required to get this natural frequency? That stiffness is called the modal stiffness. Okay, modal stiffness. Next comes bending stiffness. In the bending stiffness, the BIW is constrained at its mounting locations. Mounting locations, and the load it is applied on the floor. Then the BIW, it will bend at the center. So what it will bend at the center. So how much deflection we are getting, that we will be knowing, and then the force what we are applying at the center. Okay, so that we will be also knowing. So from that, we know that stiffness is equal, F is equal to Kx here, right? F is equal to Kx. If these first two terms are not there, F is equal to Kx it will be. So X is nothing but deformation. So from here, K is equal to F by X. So here, from here, we will get the bending stiffness. Okay. So here we will get the bending stiffness from here. So every OEM or every company, when they like prepare the BIW or when they start designing it, they will be having some target values. So those target values we need to achieve it. Those target values we will get to know from the various experiments and the past experience. Okay. Then comes torsional stiffness. So regarding torsional stiffness, we'll be seeing one video later. But torsional stiffness is how the BIW is constrained at the center in 1, 2, 3, I mean X, Y, Z. And the torsional load, I mean couple load, moment it is applied at the two ends. So it will form the couple and the body will twist it. Okay, body will twist. So when it twists, body will twist. Then we will measure the angle theta, we will measure it. So that theta we will get to know from the equation again. We will be knowing the length of horizontally, the length of the vehicle we will be knowing. At the center we are clamping. So half of the distance of the vehicle we will be knowing, and how much the deformation it has occurred in this direction. Okay. Z direction, how much the deformation has occurred, that we will see. And from that tan theta, if we apply, we will get this half of the distance of the vehicle divided by the deformation of the vehicle in the Z direction. From the tan theta, we will get the theta, and that theta we will be knowing. And we will be knowing how much torque we have applied. So torsional stiffness is tau by theta. tau by theta if we do, we will get the torsional stiffness. And as the deformation is small, tan theta equal to almost theta we can consider. Okay, so from that we will get the torsional stiffness. So torsional stiffness, bending stiffness will have its like own target value. That target value we should try to achieve it. Okay, so this is a little bit you may feel it complicated like while analyzing the things now, because this is the brief I am talking about. Everything I'm just trying to touch it. If we go in detail and if we see all the equations, then the things will be more clear regarding this. Okay, that we can see in our upcoming next sessions. Okay, so now for BIW has to join, right? Various parts will be there in the BIW. So how they are joined with each other? So spot weld is the major like type of joining process. So spot weld is used to overall BIW is joined by the spot welds. So there will be a number of spot welds. So spot weld can be used. I mean, it may be in the 2T. I mean, two parts can be joined with a single spot weld, and otherwise 3 parts can also be joined with the spot weld. So yeah, so thin sheet metals can be joined with the spot weld. And when we are spot weld locations, when we are fixing it, so there should be some minimum distance in the spot weld, like 25 mm or something, 20 to 25 mm, because when we are generating spot weld, some of the heat affected zone will form surrounding it, and because of that the material some strength of the material may reduce, right? So some standard distance will be there that we will try to keep it, so that two heat affected zone should not club or they should not overlap with each other. Then comes arc welding. So arc welding, it is generally used for the heavy parts having the more thickness. So heavy commercial vehicles and that all, arc weld it is used, or it is called as continuous weld or CO2 weld also. So two different kinds of thickness are there. Then the continuous joining can be possible, and it provides a good strength here, right? Then comes under laser welding also, laser welding. So here spot weld, so there is some possibilities there, and in the laser welding will be more accurate than the spot weld, what I can say. And yeah, so strength will be very much high. Then comes adhesive bonding. So as if you see the spot welds are, as the name suggests, it is at the particular spot only we are welding it. Okay, so in the other region the parts may not be connected to each other. So whatever the force transfers, that will transfers from that spot weld itself. But next comes like adhesive bonding. Adhesive bonding is nothing but some gum kind of liquid will be there, semi-liquid. So that we will attach with just like our Fevicol or something. Okay, some good high strength adhesive material will be there. So those are applied between the two parts and overlapping surfaces of the parts, and the parts are joined. So because of this, what happens? So the force transfer happens from all over the part. Okay, and it provides a good strength, and when we are using the adhesive bonding, number of spot weld we can try to reduce it by making use of adhesive bonding. Okay, so it provides a good strength also, and also the adhesives are light in weight. Next comes rivets. So rivets are generally they will be there on the roof or some other regions also, where the hole will be there and the rivet will be fixed there. So the design of rivets and that all we have seen our engineering. So like this. So when we do, this is just like about the modeling. Then when we do the analysis and that all, everything, the diameter of the rivet or diameter of the spot weld, everything we need to mention correctly to the software. And then we calculate, I mean, the failure, if the rivets are failing, how they are failing, how much shear load it is taking, rivets are taking, that we will be seeing. And the hemming is one more again joining techniques. It will be usually available, I mean usually present in the door system. Okay, side doors it will be there. Okay, hemming. So now when I talked right here, the structural analysis and optimization, this was from the durability perspective of view. Okay, and then if we see from the crash perspective view, there are different So whatever the points what I have mentioned, everything may not be related to the BIW, but yes, certain parts are related to the BIW. So first term comes in the crashworthiness and safety is crashworthiness. So what exactly crashworthiness is means, it is nothing but the energy management. Okay, when crash occurs, the parts go under the huge plastic deformation or permanent deformation. Otherwise, what may happen? Some parts, if they are much towards the rigid, okay, they are like more behave like rigid, then they may transfer entire energy to the occupant who is sitting inside the car. Okay, so proper energy management has to be there when the car goes under the accident. So how much energy has to be transferred, how much energy it has to absorb, so that based on that the strength, which kind of strength of the material we should use, or what, how should be the design of the parts, that comes under everything under crash worthiness. So structural integrity. So vehicle should have a strong and rigid structure capable to withstanding the impact forces and preventing excessive deformation. Okay. So because see in the crash and that all, I am speaking from the both the side that the component should have good strength also, and it should deform also. Okay, so those are based on the application in the frontal impact or it in the side impact and that all. The side impact and that all, the clearances are very less from in the occupant and this. So the excessive deformation should not be there. So otherwise directly the vehicle may come and hit directly to the occupant only. So the structural elements, so structural parts what we are using in the side impact, they should have the enough good strength. Okay. Yeah. So enough good strength, what I can say, rather than saying the good strength. Okay, it is based on our calculations again. So this is the crash energy management. So as I said in the crash worthiness, so energy management has to be proper. So from where the load is transferring and where it should go, that has to be like, we should check it clearly when we solve a problem. So side impact protection, yes, I have explained. So again, then comes rollover protection. Rollover protection is nothing but whenever your vehicle is like falling on its side or something in depth when it is falling. So that time the roof may come contact with the ground directly. So that time in this, like, what should be the strength of the roof and that all we will see. And the different kinds of airbags will be there, like curtain airbag and that all, they are deploying it or not properly, that will check. But overall, like what I can say, that the structure should have or BIW plays the very important role in absorbing the energy and transferring the energy. So it should have the good strength and good energy management role it should have. So few of the crash, like we are seeing it. So first, it is nothing but a full frontal crash video, it is there. Right, so this crash it there wherever the vehicle is coming and full front of the vehicle, it is hitting to the like rigid barrier. It is hitting to the rigid barrier. So when it is happening inside of the dummy will be there, it will behave like this. Okay, and so these are the different like possible views from the different sides. So here we should see all components, how they are behaving. So here if we see the fourth image, only the BIW parts are there mostly, and how the energy will be transferring and that all, that will be seeing here. So BIW plays the major role here in absorbing the energy and transferring the energy. Here BIW many like many things are attached here. Restraint things. Okay. Or some anchorage points are attached to here. Seat belt is attached here. So those anchorage points should not be pulled. Okay, should not be. They should not come out of the BIW, or the BIW should have the good enough strength to hold those components. So this test is known as seat belt anchorage test. Okay, so where the like some of the blocks are placed, shoulder block and lat block are placed on the seats. So those represents more like the human dummy, and the load it is applied on it, and for that load how our BIW is behaving and that all. that we can see over here. And if not, then the strength of the BIW we can improve it. So while improving the strength of the BIW, the stiffness has to be improved. So to increase the stiffness, stiffness, if you see, it is the material property and the geometrical property also. If you consider single bar element, the stiffness for the bar, it will be like AE by L, right? AE by L. So A and L, those are nothing but A is area, E is Young's modulus, and L is nothing but length. Okay. So AE by L. So A and L, those are nothing but geometrical properties, and E is nothing but Young's modulus is material property. So to increase the strength every now and then, we cannot increase the thickness. I mean, we cannot increase the strength of the material. Material change cannot be a good option every time. So rather than that, instead of changing the material to achieve the desired stiffness, so we can change the length and area. Otherwise, in short, what I can say, you can change the geometry of the component to achieve the desired stiffness. Okay, and that is the reason if you see this gray color like BIW part, so there are many beads are there on this. Okay, or some long imprints are there. Okay, those beads are do the work of the stiffness. Okay, because this is here we are changing the geometry of the vehicle or thickness of the vehicle, and we are trying to achieve the desired thickness over here. Right. So when all this happens, we should take care of the manufacturing point of view also. So what are the manufacturing, I mean, based on what parameters we need to consider, what parameters we need to consider, that we are going to see. So material selection. So material, when we are material selection should be, I mean, material should be easily available, and what should be the property of it, durability point of view, or otherwise corrosion resistant point of view, what are its cost, okay, whether it is low cost or no, and the component, the material, whether it is easily recyclable or no, that all we need to see. Because steel and that all, steel mostly it is used, steel it is very easy to recycle, but aluminum parts and that all we are using, then it is very difficult to recycle, because aluminum in its directly we cannot use it in the raw form directly into the vehicle. Some other materials we need to add into it. So that is very difficult to recycle, and composite materials are even more difficult to recycle it than the conventional steel material and that all. So these all parameters we need to consider while when we select the materials. Okay. Similar time, the cost also should be taken into consideration, because when we launch your vehicle or something, so some of the cost it will be set. So this vehicle I need to launch in some of the XYZ lakhs cost only. Okay. So whatever, if you are crossing the limit, then it is no use. Okay. People will be having some good other options to buy the vehicle from the other companies. So yeah, so cost consideration has to be taken into the picture. Okay, then comes the manufacturing processes. So what all components or what all parts you are what materials you are selecting for what parts, those parts are can go under that various processes, whether it is possible, because if it is, the part has to be formed with the forging or casting, and for that if we are using some other kind of material composite and that all, that may not be possible. So different processes are there, like casting, forging, machining, molding and that all. So for that, how that particular material will respond, and based on that we need to consider this manufacturing processes also. Then comes tolerance and fits. So for that, the material, whether it is easily machinable or no, that we need to see, because for the components, when we see tolerances and that all, so we should check this limiting of it or allowable variations in microns and that all, then only it should have the proper fit and that all, right? Otherwise, if imbalance occurs, then some interference and transition fit may happen into that, or clearances fit may come, and because of that the vibration may increase or something, or some excessive load may come onto the other assemblies and the failure may occur. So that much detailed inspection or detailed quality control, we should have control on it. Okay, then comes design simplification and that all, scalability and mass production volume. So whether if we are going for one component I have to manufacture, and suppose because when we are going right, so every target will be fixed. In 1 year I have to prepare the 1 lakh of the vehicle, suppose 1 lakh of the vehicle, and if at that time manufacturing method, if you are considering like 3D printing or something for few components, then the 1 lakh components with your 3D printing may not be possible to manufacture in the 1 year. So such kind of complex manufacturing processes like 3D printing and that all, we cannot choose in the mass production and that all. So those things, and if the component is too big or something, and that there the 3D printing is possible or no, that all we need to see it. Okay. Then assembling and joining methods. So to join that, whether as earlier I said like steel and that all can be welded easily, but aluminum and that all, it is bit difficult to weld it or something. So these all joining methods should also consider initially only. So these are some of the other things which integrate with the BIW. So BIW will be there here. For the BIW, closures will be there. Closures means the doors, hoods, bonnet, and tailgate. These are the closures. So here the transmission system will be there, wheels, okay, axle, everything. So these are the transmission system will be there. Powertrain system will be there. Okay. And the inside your all interior fitments, seating system, those all are attached over here. Okay. So these are the other assemblies which we integrate with the BIW. Okay. So last part comes is nothing but the design, testing, and the validation. Okay. So when the vehicle gets manufactured or any component or any part gets manufactured, it goes from the various stages. So initial stages are nothing but CAD or CAE, where the component it is manufacturing in the digital environment, and then it is analyzed by using the finite element analysis. Then we see whether we are getting whether that the component is properly behaving as per its function or no, or the car, or it may be assembly also, component or the assembly, whether it is behaving as per its functionality or no, that we will check in the digital environment. When we check in the digital environment, parallelly the prototyping of the same also will start. So prototyping. So once the prototype is manufactured, the prototype which is like more similar to our final design vehicle. So which will be always, then on that prototyping testing will be done, and through that we will get to know, where are our have we committed any mistakes or what, that those all are we will get to know from the prototyping testing, and that those we can improve it. Okay, if somewhere the failure and that all it is occurring after the prototype testing, then we can improve in that region and improving that area, and again we can come up with a new design, and we can that we can implement in our actual vehicles which is in the production. So similarly, is component testing will be there. So component on the single component, there may be the different tests. Some of the loads may be applied on it, durability test or drop test in crash or fatigue test, vibration testings. Many testings will be there, and the component can be tested. Okay, system testing is nothing but your sub-assembly testing and that all. So various suppliers will be there which provides us various systems and that all, or we provide our system to other vendor. So for at that time we should test our entire system and we should give it. This is nothing but system level testing. And when all assemblies come together and our vehicle forms, on the vehicle we do the vehicle testings internally or something. On road test will be there. Those I'll show in the picture. And then the regulatory or compliance testing. Few of the testing tests related to the like pollution norms, and few of the crash norms are there. Those are some of the authorized regulatory body will be there. So under the inspection of them only, we need to carry those tests, and then we should take the certification from them. Those are known as certification tests. Then comes durability and reliability testing. So for the long performance, so the fatigue analysis and that all that can be carried over here. I mean, similar one component, one part or one vehicle, if it goes under the continuous loading condition, continuous loading for long time, then under that, what are the fatigue? Will develop into it. So what is the life of it, life of the vehicle, that we will try to, calculate from the durability kind of analysis. Okay. So after that is the vehicle testing, level testing, regulatory compliance metrics, and durability and reliability testing, what I've explained earlier. Yeah. So before ending up, so I would like to show us a few of the videos. So earlier I was explaining about the bending analysis and that all. So when you are applying the load at the center of the vehicle or something, like how the vehicle will bend, okay, those things of those kind of analysis already will evaluate into our digital environment. And after evaluating into the digital environment, same physically also, that much strength, did we achieve it or no? Those kind of things we do here by, bending analysis or torsional stiffness analysis. See, soon after putting the load here, before the vehicle was like this, and after putting the load, the vehicle deforms like this. So when it deforms, it should have the good enough stiffness. Now this comes to the torsional stiffness. So Indian roads, if you see, the roads conditions may not be, your vehicle may not be go on the highway. Some improper levels, okay, of the roads will be there. So because of that, one tire may go down, one tire may be up, okay, right? So that time the twisting moment will be there in the vehicle. Under that twisting load, what should be your, proper torsional stiffness, so that we will try to achieve it through our digital calculations, and the same we are trying to validate through the physical test over here. Okay, this was the one video which is speaks about the design validation of the bending stiffness or torsional stiffness analysis. Then comes like a few of the videos which are related to the crash analysis that we can see. So this is nothing but the frontal impact analysis. So here the vehicle is coming with such a high speed and it is impacting on the barrier. So the huge energy will develop, and all the energy will transfer to the people sitting inside the car. Okay, so the BIW is the major energy transferring unit, what we can say. So the design of the BIW should be in properly, in the more engineering way. This is the side impact. So from the side, if it is impacting, how good or how strong your side structure should be, this we can validate through this side impact test. This is other type of side test, which is known as pole test. If the vehicle goes and impact on the pole, then how the vehicle will behave, that we are trying to validate from this pole test. So these are some of the other tests related to the pedestrian safety. So here that much huge role of the BIW will not be there, because most of the things hit on the bumper and on the bumper only and bonnet. So yes, so coming towards the end of our presentation, finally I would like to conclude my presentation by saying that when we design the vehicle, design of the BIW plays the very important key role, and the why it when we design it, it goes under various development will be there, and the other engineering load conditions. For that load conditions, we should design our BIW. So this was just introductory session. So I have covered the very brief of a brief from this. So detailed things can be covered in our next session. So thank you for your patience and time. Thank you. So if you have any queries, we can consider.
Thank you. Thank you.
Sir, kindly share the PPT in chat.
Yeah, I'll share it.
So, where we will get the free certificates and all? Hello?
Hello, host.
Yeah. Sir, where can we generate the certificates for this course?
The host will answer this question.
Okay.
So please share the PPT in the chat.
Yes, I'll share it.
But I have a question.
Hello.
Hello, yes.
Sir, I have a question. When we will doing the course, then you provide the softwares of the pad and CI, sir.
Sorry. See, basic.
Then
Yeah. So the CAD is CAD. I mean, the CAD can be like the CATIA is the main software. CATIA and Creo. CATIA and Creo are the main softwares required. Or see, softwares are many. Okay, the everything you can
Sir, I want to ask that the software which we will work for the design, then that software we will provided by your side or we have to arrange?
the host will answer this question.
Sir, please host answer.
Hello. Yeah, Priyanshu.
Yes, sir.
Have you enrolled in any of our courses?
Yes, sir. I enrolled in this course for the.
You enrolled in?
Sorry,
I didn't get you. I'm not able to hear you properly.
sir. I have enrolled in this course, so that's why I want to know that the softwares which we will work as a
You
design.
will be enrolling in the course.
Yeah.
Okay. See, like the software, we will be helping you getting it downloaded from the website itself. Okay. Our mentor, once you get enrolled, our mentors will give you the mentorship, how to download it and from where you have to download it. And if you are a student, then definitely on your email ID, you will get the free access of some of the softwares.
But I am not. I am working professional, sir.
Yeah. So in that case as well, our mentor will help you how to get the software.
But the software we charges for their license, sir. So that license.
See, we will be not giving you the paid license if you enroll in any of our courses, because the cost of the license itself costs too much.
Yeah, I know that, but we don't have access to that. Then we have to pay for that license, no, sir.
No, our mentor will let you know how to get it done. Okay. We have some of the tie-up with the Altair and all other companies, so they will help you how to get it done at your end.
Sir, but I want to ask that will be the for the
So Priyanshu, as you will be enrolling for the course, I think you can get connected with the counselor and they will give you the correct guidance according to for that.
Okay, sir.
Yeah. So it's.
Sir, for me, I have a doubt. Where can you share the link for the certificate?
Certificate link will be shared to you on the email once the webinar is done. You will be receiving the email within 2 to 3 hours on your, and you can download the certificate from there itself.
Yeah. Thank you. Have a great day.
Thank you.
So please share the PPT, sir.
I'm not able to get it where to attach it. Attach option, I'm not able to find it.
Yeah, Sanjay sir, we will be sharing that in the course itself, where we will be giving them the recording, so we can share them at that time itself. So we do not have to worry about it.
Okay.
So guys, if you guys have any query related to the webinar or anything, you can ask it right now. For all other queries, we can discuss it later, because Sanjay sir has his tight schedule. So if you want to ask any questions right now, you can ask it right now.
So how to join this BIW course on this webinar session, sir?
See, like we have a courses that is a 6 month, 9 months, and a 12-month courses. So that is not completely based on the BIW. We will be touching all the parts of the designing, the other software, SolidWorks, Ansys, Hypermesh, LS Dyna, all other things. So we have a complete package of these courses available with us. You can easily give us the inquiry regarding these courses, and our counselor will get back to you.
Thank you, sir.
Yep. So we will be sharing the link to give the inquiry. You can fill up the form, and our counselor will get back to you. I request Hardik to share the screen, or like if you can share the link in the chat box. So guys, if you have any query related to the webinar, you can ask it right now.
Sir, good evening, sir.
Yeah, good evening.
Hello.
Yes.
Sir, So my name is Dr. M. Sivaram Krishnaya. I'm working as Associate Professor in SVR Engineering College.
Okay.
Regarding BIW project, is the any type of software you can do that BIW project? Like type of supports like a SolidWorks, CATIA Pro E.
Sanjay sir, can you address this?
Yes, see, designing, again, there are multiple things as I explained. See, CAD design is one of the thing. CAD design is one of the thing. So every CAD software has its own limitation and advantages. So yeah, so in CATIA supports good for the BIW designing, what I can say. But in other softwares also it is possible for designing. So this is, we should have the proper detailed design of it. So this is from the CAD perspective of view, and in the CAE perspective of view, if you see for the different loading conditions, it is nothing but actual design or calculating the strength of it and that all. So there are different like domains, like durability point of view you have to design, or NVH point of view, or crash point of view. So for the durability, the like Abacus, Nastran, and the FEMFAT, these are the things. So for the for the NVH, Nastran supports very good, and for crash analysis, LS-DYNA supports very good too. LS-DYNA, Radios, Pancrash, these are the softwares which supports very good. So it is a used the domain. So designing is not nothing. It is not only about the CAD designing. It is overall designing. It takes in which area you have to be masterized, that we need to think of, and then we have to select the softwares accordingly.
Yes, sir. Suppose I'm going to give the training for our student for automobile sector point of view. Is there any opportunities like students are going to get opportunities like any type of companies they're offering like BIW projects?
They will get the job. Getting job is some different thing. So yeah, they will get the job after, like, if they have the capabilities. The companies are looking for the students or the people or freshers which know the things rather than the fresher things. Everywhere experienced people are much preferred than the fresher. So the people, for them it will be easy to spend less time on training directly. But directly companies, that your management has to manage that. They have to bring the campus to your college and that all. Through that it can happen.
Okay, so what I'm thinking, my doubt is, suppose I'm going to give the training. I have this experience in the BIW project, like a very long back, like 5 years back, I worked in Wipro company. Now
Okay.
5 years onwards, I'm in teaching field at the time, the present. Now I'm giving the training for BIW point of view, some trainings, but the job opportunities, I'm not going to get any industry now, like any type of application, I'm not going to get any type of industry. Is there any, if you are going to give the like opportunity, if you are going to show the opportunity, that is great for me.
That host will answer. They know. I'm from the technical part. The host and management, they can take care of it. How the job openings and placement and that, they will be taking care of it. The host can.
So guys, we are having courses for the professionals plus the students as well. Okay. So those who are interested joining our electric vehicle programs, so they can directly join our program. So I am displaying our QR code. Okay. So those only enroll those candidates who are interested in our courses. Okay. Certificate link will be shared after 7 p.m. to every of the guys. Okay. So you can download the certificate. It will be directly shared towards a mail. Okay. And for the feedback or regarding the webinar, we have mentioned the link in the chat box. Okay. So you can give the feedback as well. So for any course queries, you can scan our QR code. Okay. This is only for the courses, because we have a different programs for the working profession and the academicians and the students. Okay. Apart from that, we are having pay after placement programs as well. Like those students who are looking for a job, so they can directly enroll to our courses. Initially, they don't have to pay any amount. Okay, they only have to pay after getting the placement. Okay, so for those, we are having the program as well. This program is only for the final year students and the pass out students. The pay after placement. Rest candidates who are pursuing in the first year, second year, third year, or the working professional, they can opt for other programs as well. Like we have the name from the professional mother certification program and the PGP program. Okay. So for the course related query, you can scan our QR code, and our technical counselor will connect with you within 24 hours after the scan. Thank you, Sanjay sir, for the webinar. It was a very nice webinar that you have delivered. I hope
thank you.
All the participants gather too much knowledge about the BIW and design.
Yes, thank you so much. Yeah, thank you so much. Thank you.
So participants who are interested in our courses, they can directly scan our QR code. Thank you, participant, for joining our webinar. Have a great day ahead. And certificate link will be shared over the mail after 7 p.m. You can directly for a certificate.
My name is Jagadish. Can I speak with Sanjay?
Yeah, Jagdish.
Hello, sir. It was a great presentation. Actually, my question was you shared with BIW and the concepts and a few things about it. So, exactly, if you are working on a company, so they won't provide entire BIW as a new product development. Existing only they will be modified. So, how the knowledge which we gain through your session,
Okay.
BIW project.
Apart from the webinar, if you want extra knowledge about the BIW, okay, so it is delivered in our program as well.
No, this is not about the course I'm asking. Where it will be applicable, what kind of things we will this BIW will be used in companies that I'm asking. We are not going to
Your voice was human, was not completely audible. Can you please repeat your question once again?
Now it's audible.
Hello.
Hello.
Give me a minute. I'm inside from the different laptop. Give me a minute, please check it.
My voice audible?
Yes, Jagdish, you can speak.
Actually, my question was learning this BIW, we are working on a company, we are not going to build an entire BIW newly. So how learning this kind of stuff is useful in a company who's working on this project, this kind of project? Is my question clear?
Yes. So I'll try to answer your question. Just take it.
Okay.
See, as I said, right, you are not going to work on the entire BIW. You said it is correct. I mean, see, but when you're working in any of the thing, I mean, suppose any of the domain, though it may be durability or NVH or crash, okay, or you are working into the CAD, okay, somewhere some part of it will be help. Here we are going to cover, I mean, everything we are going to cover, but it's up to you. We will be telling here from the start to end how we are going to design it. Okay, so but where you are getting interest, it is left to you. I mean, if you are getting interested in the crash kind of load cases, you can set your career into the crash analysis. If you are getting interested into the NVH kind of load cases, so you can set your career into the NVH. So like that, it may help.
Okay. Thank you, sir.
Your question.
Great session.
Yeah. Thank you.
Any other question that you want to ask, learners?
Yes. So can I sign off?
Yeah. Chandra, you can sign up. Thanks for the webinar, sir.
Yeah. Thank you so much. Thank you so much. Have a great day ahead, everyone.
You too also, sir.
Yeah.
Thank you for the organizer also. It was useful.